Station.
Good afternoon and a very warm welcome to the third day of our international webinar on linguistics, machine learning, and uncertainty theory. Yesterday, we really had a very enlightening talks uh, from truly great personalities like Professor Baoding Liu, the father of uncertainty theory from Tsinghua University, China, and from Jingpeng from Wangang Normal University, China, and also from Waishun Liu from Bahang University of China to deliberate on uncertainty theory, its advantage over other theories in various situations, uncertainty statistics, and a quite new concept. Also, yesterday, Professor Payne uh, introduced before us that is uncertain network optimization. And today, to grace this webinar, we have again with us some very eminent speakers from diverse areas from different parts of the world, starting from Serbia to Samaria, and definitely including my India. And this whole session would be chaired by our Honorable Dean of School of Engineering, Professor Torun Kantijana of Haldia Institute of Technology, an expert mechanical engineer, and a scholarly person working in interdisciplinary field of mechanical engineering, AI, and cognitive science. And now, to start with, we are having Professor Ivana Tajner Papuga, belonging to the Department of Mathematics and Informatics from University of Novi Sad, Serbia. She is a true scholar in her field of study, and today she is going to deliver her talk on fuzzy measures and integral aggregation operators in decision-making theory. She's an active researcher and has been the author of numerous research articles like Conditional Distributivity of Continuous Semi-T operators over disjunctive uninorms with continuous underlying T norms and T conorms, corrigendum to distributivity and conditional distributivity for T uninorms, relaxed distributivity, laws for semi-T operators and disjunctive uninorms on solutions of distributivity equations for causal linear means. So many are there. If I continue, I will not be able to finish, and we will keep on waiting. So
Oh,
now I request Professor Stajner to kindly deliver her talk and enrich us. Over to you,
thank,
madam.
thank you so much for this nice introduction, and thank you all for this invitation to present at this very nice and as I've heard very uh, well well watched uh, seminar. So as you see, the topic is about fuzzy measures and integral aggregation operators. And I will give you a presentation that is pretty much mathematical, but I will try to present you some basic ideas that I find to be very interesting and hopefully very applicable in different areas. So first of all, yes, I should introduce myself a little bit. I come from University of Novi Sad. Novi Sad is the second largest city in Serbia, and we have very nice university. And I come from Department of Mathematics and Informatics, which is part of our Faculty of Sciences. And I'm here actually thanks to the recommendation of my dear friend and colleague, Andrea Tepavcevic. We've already mentioned her before the official beginning of this presentation, and we do cooperate. And you will see in slides, we have some nice ideas concerning these fuzzy measures. So let's start. First of all, I'll give you some historical background. Will not go too much into details, just to give you some idea where these fuzzy measures are. Of course, when I say measure, first thing that you think about is classical measure. Yes, it's connected. And if there is a classical measure, we have to talk about probability. So just a few ideas, few years, just to give you some basic background. When we talk about classical measure, okay, we have a set function, it maps sets to certain values, and what we know about classical measure, non-negative, empty set always ends up in 0, and of course, big, 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 big big thing that has to be fulfilled is this sigma additivity. That is our classical measure, classical approach. You'll see this is a little bit softened for fuzzy measures, and since it is softened, it can be applied in wider area. And just historically speaking, this classical measure, where in which years you can find beginnings of this classical measure. As you can see, it goes to 1898, Borel, then we have Lebed in 1900, then of course Kolmogorov, this nice axiomatic approach in 1933. So it is really, this classical is a really good word for this measure. Of course, as I already said, it's really, really closely connected with probability. So again, few words to give us some historical background. When we talk about probability, we can go as far as to 16th century, game of chance. But then it was just a game of chance, this Cardino guy. But in 17th century, it really started, and that's funny, it started as a gambling dispute that Fermat and Pascal had to solve. That is very interesting. The real nice classical interpretation goes from 19th century, you know, nice interpretation with nice formulas, nicely put as a theory, thanks to Laplace, and axiomatic approach. Kolmogorov, again, this 1933, he connected somehow this probability as a core and upgraded it to this measure theory. Of course, probability measure is one option for a measure. We have all different types of measures. Now, this...
excuse me, Professor, excuse me.
Yes?
If you open your camera, so it should be very easy to understand your lecture. If you open your camera,
You want to see,
so
my
actually we
camera?
cannot. Yes, yes, yes.
Okay.
Your face is
I
not
can...
visible.
yes,
No,
I
no,
know,
I
because I
only
turned it
want.
off. Because of upload.
Oh, okay, okay,
Because
okay.
of
Please
internet.
continue.
Okay,
Please
we'll
continue.
try. We'll try. No problem. We'll try with camera. If it doesn't work, we will
So
put it out. No
actually,
problem.
we are participant. If we see your face, so we'll easily understand. Now it is okay. Now it is okay.
Can you see me now?
Yes, yes, absolutely,
Okay,
absolutely.
we'll try.
Okay, please
If
carry
internet... Yes.
on. Okay, now okay. Please carry on.
Mm-hmm. Oh, we're back. Okay. So
Okay.
let's connect this probability, actually measure theory, with decision-making problems. And then you will see where we can put this softened approach to decision-making problem. When we talk about decision-making, we, of course, this is classical setting. We have set of alternatives, set of states of worlds, set of outcomes. Of course, there is a function that connects all that, and there is preference relation. Preference relation, we have to prefer one outcome to another, quite normally. Now, probability, we can use probability to model decision makers' behavior. Probability there is one possibility, is to assign to state of the world, because here we have state of the world, that is what can happen around us, and related to that, what can happen around us, we will know the outcomes, and we will choose the action that is the best for us. So there is one option to assign probability to our set of states of the world. We can find probability there. but also we can use probability to model this preference relation. So which outcome will be better, the one with higher probability. Now, this whole setting can be upgraded because usually this set of outcomes is, how to say, the easiest way to understand it is through amount of money. If you have to make a decision, you have some alternatives and some outcomes are actually some amount of money, and you will be able to choose what is the best outcome for you, of course related to this amount of money. But this can be changed a little bit. This can be, so to say, translated to human thinking with utility function. Think about of this problem. There is a child, 7-year-old child, and his aunt is coming to visit, and she's bringing him a present, and he can choose. He can get a really nice big chocolate, or he can get some very nice amount of money. He can choose. Let's say that this amount of money is actually more than the worth of chocolate. But this kid loves chocolate, and he knows that his mom will not let him spend this money on chocolate. So if he has to make a decision between these two actions, he will choose chocolate. Why? Because utility of chocolate for him is bigger than utility of money. So this is this utility function, and it actually appeared first in 1738. Bernoulli introduced it, utility function over wealth. So when we talk about decision problems, we have to take in the account opinions, feelings of a decision maker. People's internal subjective value for an amount of money is not necessarily equal to the physical value of that money. Very interesting approach, and there is lots of space to incorporate new techniques and new ideas in this utility. So another interesting reference for decision making is this one from 1921, Knight. This distinction between risk and uncertainty. This is very interesting. This uncertainty is especially very interesting. Risk, you have some information about those states of the world. You have some information in the form of probability. Okay, it will help us. But uncertainty, you don't have any additional information, and you have to use some non-standard tools to extract the optimal action. Of course, we cannot forget Neumann and Morgenstern from 1944. Expected utility, again, utility over lotteries. And of course, there is this nice work from 1957, Look and Raifa, subjective probability. So this is some historical overview how this probability is developed. Probability, actually, decision-making problems are being developed through years. See, risk, we have probability in this risk part. There is probability hidden. Utility function, we have probability also. It is a step further. It's not just probability that outcome will be better, but this is personal opinion which outcome is better, that is being modeled by a function. You can see here, outcome X is preferred to outcome Y if utility of X is bigger than utility of Y. So we have here one new step. Now, for now, I was talking about probability. You can see we can put it in this decision-making surrounding. We know where this probability can be used. But Here is very well-known Ellsberg paradox from 1961. It shows some problem that can appear when you are using probability to model human behavior. A very nice example. I love to show it to my students. Imagine this situation. You have two gambles, gamble A and gamble B. Again, setting for gamble A, there is a box that contains certain number of red marbles and certain number of black marbles. We don't know exact number of red, we don't know exact number of black, but altogether there is 100 marbles in this box. Gamble B, your box, it contains 50 red marbles and 50 black marbles. And a person is asked to decide between gambles where that person will put his or her money. Usually, people provide answers like this. If they have to play this gamble A, they really have no preference between red and black. Why? Lack of information. They know that there is some red and some black, and usually because they don't know the exact number, okay, doesn't really matter. The same situation goes with gamble B, because they now know that there is 50 red and 50 black. Okay, so it's indifferent between gambles B red and B black. But if you ask them to choose between gamble A and red marble and gamble B and red marble, big number of people will choose this gamble B, this box where they know what is the situation, because they know what is happening in this box B. Maybe situation is better in this box A, but they don't have this information. So somehow that's reason why they choose this box B. Same situation with black marbles. If you ask them to choose between gamble B and black marble, gamble A and black marble, again, majority of people will choose this gamble B because they know what is happening in this box. And now, if we use probability to model to explain this behavior, we can use probability. What does it mean? Well, probability for these two are the same. I mean, we don't really know if they are the same, but opinion of our decision makers is that this is the same. Here we know that is the same. And opinion of our decision makers for these two situations are like this. They think that probability for this situation is greater than probability for this situation, and probability for this situation is greater than probability for this situation. This is opinion of our decision maker explained or modeled by probability. But where is the problem? See, here is the problem. If we accept this probability, we get, see what we get. We get 1/2 strictly bigger than 1/2. Something is not working. Where is the problem? Exactly here, because this is probability, it is additive, and this additivity is causing us problem. So additivity in this probability is too rigid, too strong, and it makes problems with describing this particular decision maker's opinion by probability. So the idea is to soften this probability. How? First, ideas appeared in Choquet work and in Sugeno work. As you can see, 1957, 1974, they softened this additivity. How? additivity was abandoned, and only monotonicity was required. Now, in Choquet work, this new set function that is called capacity was introduced, and this is all that it was asked from this capacity. It should be increasing. It should be strongly sub-additive. See, we don't have additivity, but we have this strong sub-additivity, and it has to be continuous. This is step one. We are getting here something that is a little bit easier to use than classical probability. But Sugeno is continuing this work separately. That is very nice. That is very interesting that they came up with this idea independently one from another. And his proposal for his set function is that it vanishes at empty set, okay, that is increasing, and continuity from below, continuity from above. This actually one idea, but from two directions, continued to develop. So we have belief measures, additivity there is replaced by superadditivity. We have plausibility measures, additivity there is replaced by subadditivity. That is Dempster and Sheffer theory. You can see 1967, 1976, all the way to Zadek, Dubois, Prade, where we have possibility measure. As you can see, measure of union is expressed with supremum. Necessity measure, again, very nice theory, but we have here intersection expressed by infinitum until we finally get fuzzy measure. Fuzzy measure or monotone set function. It's somehow all these measures that you've seen so far are leading towards fuzzy measure, and we finally have fuzzy measure. Mapping means that maps family of sets into interval is fuzzy measure if it maps empty set to 0 and if it is monotone. That's all. Bare bone structure. That's all what we need to have fuzzy measure. There is a discussion about this name, fuzzy measure. This word measure can cause a little bit of discussion, because if you say measure, you automatically think of classical measure, which is sigma additive. But here, fuzzy measure does not have to be additive. Only thing that it has to be is monotone. So quite often authors are not using fuzzy measure, this term. They are using the monotone set function, this whole description of this set function, monotone set function. Or if they are more orientated to Choquet research, they are using word capacity to describe this fuzzy measure. I like this name fuzzy measure, so I kept it here for this presentation. So fuzzy measure, only thing we need is monotonicity, monotone set functions. We don't have this rigid additivity that appears in probability. Don't take me wrong, probability is absolutely perfect and interesting and useful, but sometimes it's too strong. To avoid this, let's go to fuzzy measures. Now, different types of fuzzy measures are possible. We've already seen some examples, but quite often we use S measures. See what is happening here. We have operator known as triangular conorm. This triangular conorm is quite an interesting operator. It actually somehow extends addition, so to say. It has to be commutative, associative, monotone, and it has a neutral element. And we can use this triangular conorm instead of additivity with our set function. So if we talk about S measures, we know that measure of union, of course, these are disjunct sets, measure of union can be calculated with this triangular conorm and measure of each set and measure of each of those sets. So this is one option for our fuzzy measure. Those measures are called S measures. You can find more on S measures in this very nice book from 2000, Clement Messer-Pack, Triangular Norms. Then, okay, what else can be? So there is whole theory called pseudo-analysis, where pseudo-addition and pseudo-multiplications are introduced. And based on those operations that are generalization of classical addition and classical multiplication, we can have sigma O plus measures, so to say. You see, now classical addition is replaced with this special pseudo addition. Again, very, very nice to soften this classical addition and to get a set function that is easier to model according to decision maker requests. So you see, measure of union is actually expressed with this special pseudo addition. More on this, for example, in this reference from 2002, Handbook of Measure Theory by Elsevier. All that are actually somehow aggregation operators, and part of this this presentation is also aggregation operators, not only fuzzy measures, but aggregation operators, special aggregation operators that we can construct based on those fuzzy measures, because if we use fuzzy measure and we describe the decision maker's behavior and opinions with it, and we construct aggregation operator, this aggregation operator will help us to make decision, but on starting assumptions that are typical for our decision makers. So in general, again, very simple, very basic definition. If we talk about aggregation operator, it's a mathematical tool. It can have n inputs, one output, but it has to be non-decreasing with respect to all variables, and it has to satisfy boundary conditions. Quite logical boundary conditions, and very, very in the spirit of human thinking. See, if all inputs are horrible, output is horrible. If all inputs are perfect, output is perfect. So these are aggregation operator. Of course, we can request from our aggregation operator to be commutative if we need commutative. We can request from our aggregation operator to be associative if we need associativity. We can request continuity, so we can request different properties depending on the problem we are trying to solve. More on aggregation operator, very nice book, Aggregation Functions from 2009, Grabisch, Marichal, Messier, Papp. We have different aggregation operators. I will not go to hold this list. Well, this is just a part of list. I will go directly to integral aggregation operators because those aggregation operators are interesting to us. We have different aggregation operators depending on which measure we are using. So if we use monotone set functions, the most general approach, the fuzzy measure in the most general option, we can get Choquet integral. Also, we can get Sugeno integral. In a moment, you will see difference between those two integrals. If we use S measures, I've mentioned them before, we can get ST integral or SU integral, depending on this second operation, whether it is a T-norm or uninorm. If we use that plus measure, that pseudo-additive measure, we can get pseudo-integral. All this is generalized into so-called general fuzzy integral. And now we have a lot of research concerning universal integral, actually axiomatic approach that will somehow cover all these interesting options that we've seen here and some more. Now, shortly, this is the interesting part, how this integral aggregation operator works. This is discrete setting because discrete setting is usually that we need in our decision-making problems. If it is discrete setting, we have a simple function. This is the assumption, not very problematic. And we have measure. We will require from this measure to be fuzzy measure, which means empty set ends up in 0 and it's monotone. We will not ask for anything else at this moment. It maps, of course, all subsets of X to a certain value. This is our setting. Choquet integral of an arbitrary simple function is calculated like this. You can see here is difference of values of our function, and here is important part, measure of this set where our function is greater or equal to this omega 1. Exactly here we incorporate opinion of our decision maker. Of course, this is formula for discrete case, and that's why it is sum. We have very nice interpretation of Choquet integral for continuous function, but that is not what I want to show you at this moment. Sugeno integral, quite similar. Again, values, and again, measure of this set. We incorporate the opinion of our decision maker through this measure. As you can see, it's minimum and maximum. Somehow, instead of addition, you use maximum. Instead of multiplication, you use minimum. This is very roughly speaking, of course, but that is some general idea. So these are two very interesting aggregation operators. Here is an example, very nice example, about grading students with Choquet integral. I did present this to my students. They actually told me that they would like to be graded with Choquet integral. Usually when we grade our students and we want to calculate mark for the end, we use arithmetic mean. But this is maybe better. Observe this situation. If we have 3 students, of course, this is school that is primary based for science. So mathematics and physics are very important. But of course, language is necessary. Everybody has to be literate. So we have 3 students. Student A has marked for mathematics 18 points. From physics, 16 points, but he's lacking from language and has only 10 points. Student B, he's not really good in mathematics, a little bit better in physics and good in language. And student C, as you can see, he's okay from all 3 subjects. And now we have to recalculate and see which student is the best. But this is science-oriented school, and these are the opinions of board of directors. For them, mathematics and physics are equally important, and measure for mathematics and physics is 0.45. Language is of course important, but maybe a little bit less than mathematics and physics. So measure for language is 0.3. Here is the interesting part. This is what fuzzy measure allows us to do, and probability wouldn't. Measure of mathematics and physics together. See, it's 0.5. It's less than measure of mathematics plus measure of physics. So apparently this is not additive. What is the reason behind this? Board of the directors thinks that mathematics and physics are Okay, I will not say similar, but they have some joint points. So if you put in effort in mathematics, you have to put just a little bit more effort in physics, and you will good from both subjects. You don't have to put double the effort. On the other hand, mathematics and language, or physics and language, together are 0.9. What happens here? Well, mathematics and language are completely different. And if you put effort in mathematics, you have to put lots of efforts also into language. That's why value of mathematics and language, or physics and language, is actually greater than value of mathematics and plus value of language. So this is opinion of director board, and we use this measure and those marks and calculate marks for our students. We use this formula. You see here is our measure opinion of board of directors, and here is the result. You can see if you use arithmetic mean, classical arithmetic mean, you will see that student A is the best one. That is the student that is good in mathematics and physics, but really not doing his best for languages. But in Choquet integral, the best student is student C. If you remember, that is the student that had pretty decent grades in all three subjects. It means that he did put lots of effort in all that. So this Choquet integral extracted this student that was trying hard for all three subjects. So this is this nice example for Choquet integral. That is all example from 1960, let me see, 1995, from Grabisch, Nguyen and Walker book, very nice book, and very nice starting point for further research on this topic. Since time is really running, I will go very quickly just to give you an idea where this measure can be found and this integration. Here's a work from 2016. This is covering location problem. We had a problem to solve how to find the best positions for some facilities on some offered locations, and that was the idea. We made the Choquet based model, and we made Sugeno based model. Idea was to assign measure to all these facilities and their interaction, to see how these facilities are strong separately and how they are strong together, and depending on this, how they are strong separately and strong together, to put the best possible position so that the biggest area is covered with facilities. When I talk about facilities, for example, hospitals, so that the biggest area is covered with adequate facilities, and that all this how to say, interaction of those facilities is taken under consideration. We used S measure for that, and we concluded that if you use here are some special triangle conorms. If you use this triangular conorm, then we have that strongest facility dominates all others. If you use this SP that is from product, facilities somehow complement each other, but with overlaps. But if we use SL, that is Lukasiewicz, facilities again complementing each other, but overlaps are really, really small. So we did use S measure in this example. In example 3, very, very briefly, the idea was to extend some notions from statistics, but in cooperation with fuzzy numbers. Actually, we did try to calculate some arithmetic means for fuzzy numbers, but fuzzy numbers, they have its layers, these alpha cuts, and the idea is to allow those alpha cuts to have different importance, and that's what we did. We used this fuzzy measure to determine importance and interaction of different alpha levels. And based on that, based on this fuzzy measure, we did obtain a possibility to calculate mean value for our fuzzy numbers. Of course, this is a little bit developed a little bit further about variance, and what is very interesting, which actually holds for everything else. Fuzzy, all these constructions are fuzzy measure sensitive, which means that if you change this measure, the outcome, of course, will be changed, but in this manner. If me1 is smaller than me2, the outcome will be in this same order. And example 4 is something that we am currently working on with Andrea Tepavcevic. We are using this Choquet integral in ranking crimes. This is something that is being done under this cost action for ASP, so for forensic, for digital forensics. Idea is, here you see fuzzy sets. Okay, we use fuzzy sets for some starting point, and we use membership function to obtain these simple functions. And then we have monotone set functions. Monotone set functions are used, or fuzzy measures, are used to describe different segments of our data, to tell us how important each segment of this data is, and how important is interaction of those segments. And then with this measure, with Choquet integral, we can calculate level of danger, for example, for different crime. This is quite interesting, this joint importance of different segments, because it needs to be calculated. The idea here is that if we have two segments, joint importance is, of course, bigger than importance of first segment and importance of second segment. If we have third segment added, the joint importance of these three elements is stronger than joint importance of those first two elements and this third element added. And we want to emphasize somehow to get a stronger importance with adding new segments. Here we are trying to use even non-commutative and non-associative operators, aggregation operators, to model our fuzzy measure. So this is this idea. Important of each segment, okay, experts will give us opinion, but we will use some calculation to get importance of two segments together, importance of three segments, and so on. Of course, this measure is then base for our Choquet integral, and we will calculate Choquet integral, and with this result, we will be able to rank different crimes and determine which one is the most severe one, for example. So the important thing is how to teach fuzzy measure to think as a particular decision maker. And fuzzy measure, because of its flexibility, can be modeled, can be in that form to reflect particular decision maker's opinion. Okay, this is what I wanted to show to you. Here are some references, and thank you for your attention.
Thank you so much, madam. for such a nice deliberation and the way you're so spontaneously explaining each and every thing of your presentation and so nicely reasoning with simple examples like children making decision to choose spending money in buying the chocolate or saving it. And
Well, that example is from my son.
okay, that means very real life examples you are citing.
That is real life example. Yes.
Yes, absolutely. And we were really enjoying it because we never felt that you were somebody uh, from such a distant place. We are having this feel that we are having a very good teacher teaching us something, and she's a
Thank you.
very close person to us. Means it was a very real life example and a universal example indeed. In fact, in our house also, same thing happens, and very nicely you have applied that one in this decision making explanation. How do we make the decisions and what are the things that to be taken into account while making this decision? And another thing also you have so nicely pointed out that why you are choosing the term measures. uh, I mean, you prefer to use the term measures to anything else. It was really an insightful talk. Thank you so much. And now our
Thank you.
chairperson will be saying a few words. Over to you, sir.
Okay. Good afternoon. Am I audible?
Yes, sir. Yes, sir. Absolutely.
Okay. So very good afternoon to all the people present over this particular meet and attending this webinar. Thank you, Professor Dr. Ivana Sanjan Papuga, for your nice presentation on the very emerging topic, that is fuzzy measures and integral aggregation operators in decision making theory. But before I sum up, just I have got a one question for ma'am.
Of course.
Okay. Can this technique be successfully applied in case of multi-criteria decision making problem?
Sorry, can you repeat? You have an echo behind you.
Uh, can this technique be applied for multi-criteria decision-making problem,
Sir,
MCDM problem?
multi-criteria decision-making problem. Can this one be applied in that one also, ma'am? That is sir's
In which,
question.
where can it be applied? I'm
Yeah,
sorry.
yeah, yeah. Multi-criteria.
Multi-criteria decision-making.
Multi-criteria.
Yeah,
Yes, 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 yes.
multi-criteria decision-making.
Yes,
Yeah.
definitely. Multi-criteria decision-making problem is also closely connected to utility functions to hold this structure. So why not? Yeah.
Okay. So thank you very much, ma'am. So ma'am has very lucidly explained the different aspects of this fuzzy measures and its integral aggregation operators in decision making theory. She has started with the historical background and the classical approaches, the probability measure, decision making problem, and how to model the decision makers' behavior by the probability. And another very important aspect ma'am has already explained, that is the how to distinguish between the risk and uncertainty, followed by non-additive measure why and how it has to be utilized. The one good example, the paradox, the ma'am had mentioned the Ellsbury paradox by citing the example of gamble A and gamble B.
Exactly.
Fuzzy measure, monotone set functions, S measure, plus measure, and finally aggregation operators. So integral aggregation operators in discrete setting. The two approaches ma'am has mentioned, that is the Choquet integral and another is the Sugano integral. The Choquet integral ma'am has explained in the four different examples. And what is the very interesting part of this presentation, in every slide almost she has incorporated a lot of references so that one can consult those things for the enrichment of the topic in its full perspective. So thank you, ma'am, for your nice presentation and making you available for this presentation. Over to Priyanka, ma'am.
Thank you.
Thank you so much, ma'am. And now, with your permission, and hope in near future we will have again such a nice teacher to teach us some of these aspects. And today, with your permission, we would like to move on to our next speaker. And now we are having our next speaker, Dr. Moti Zwilling from Ariel University. He is the senior lecturer of business administration in the Department of Economics and Administration, having keen interest in machine learning and data mining, recommendation systems, information retrieval, information security and behavior across the internet, development of methodologies and technologies for analysis of big data and business intelligence tools. Dr. Moti manages a number of projects also that use theoretical and practical knowledge to solve problems in the area of protection in cyberspace, especially in all pertaining to identifying users by keyboard characteristics, behavior characteristics, text analysis, and more. Dr. Moti also deals with analysis of behavior characteristics of attackers across the opaque internet. So we can understand that he has also a very keen interest in cyber security. And today, Dr. Moti is going to deliver his talk on application of uncertainty theory in business management. Now, over to Dr. Moti Zwilling. I think Dr. Moti has already joined, is here. Am I audible, Dr. Moti? Am I audible? Hello? I think there is some technical issue, and probably for that particular reason, um, he's unable to talk. Anyway, we'll just have a discussion on this present topic and would wait for the next speaker. Professor Torun Kantijana, sir, are you here? Torun, sir? Yes,
Uh,
yes, sir. Sir, I think Dr. Moti is willing is having some issue in joining. Okay, and he will be joining soon. He was there, I believe, and just before a while, he got disconnected, most probably. I'll just try to uh, reconnect him. Anupam, sir, Anupam, sir, am I audible to you? Actually, we are having some technical issues. Just we are requesting the audience to kindly bear with the situation, and soon our next speaker will be joining. And Professor Ivana Stagner was having a brilliant deliberation brilliant presentation on her topic, the fuzzy measures in this decision making. It was really very interesting, and here we are getting to know about so many new things. And okay, I think we are getting back the internet connection, and Professor Jana has also joined. Now, sir, what was your opinion regarding this Ivana Stagner's presentation? It is really brilliant.
So, uh, good afternoon, everyone. Actually, my network is not working here. So,
Absolutely.
in spite of this, what I have understood, it's a outstanding lecture. So, I will follow my recording. The net just has coming now, so I will follow. So, I hope we will learn more from Professor. Madam, please go ahead.
Yes, Dr. Moti Zwilling is unable to join, I think, and probably he would be joining soon.
Actually, I am talking from my mobile phone.
Yeah, I
There is a
understand.
lot of problem going on. Please.
Yes, I understand, but Dr. Zwilling is also having some issue in joining. He could not join till now. Dr. Moti Zwilling is also awaiting. I mean, he is having some issues. He could not join till now.
Okay, please wait a few
Yes,
minutes.
yes,
I hope
yes, yes,
he will join.
yes, yes, yes. হ্যাঁ তরুণ স্যার, হ্যাঁ স্যার, ও ভদ্রলোক জয়েন করতে পারছে না। আপনি যদি কাইন্ডলি একটু ডিসকাশন করে একটু ম্যানেজ করেন। আমি চেষ্টা করছি এদিকটা করার। ওই মানে উনি সামারিয়া থেকে জয়েন করবেন, কিছু একটা অসুবিধে হচ্ছে। আমি কোনটা কোনটা স্যার? হ্যাঁ হ্যাঁ স্যার, আপনি ওইটা করুন, তার মধ্যে আমি চেষ্টা করছি জয়েন করে। ঠিক আছে, আমি অন্য কিছু একটা ব্যবস্থা করার চেষ্টা করছি। ঠিক আছে স্যার? হ্যাঁ হ্যাঁ স্যার, হ্যাঁ হ্যাঁ। Unfortunately, we are having this issue that because we can understand that they are all joining from various parts of the world. She was from Ivana Stajner was from Serbia, and our next speaker is going to join from Samaria. So please bear with the situation. And now Professor Torun Kantijana will be sharing his experience that he has been experiencing from day one. Sir, please share your experience, kindly.
Okay. Good afternoon, all the members. First, I would like to congratulate all the members of the Applied Science Department, particularly the organizer, who have taken this wonderful initiative for organizing this 5 days webinar on the very emerging topics, machine learning, linguistics, and uncertainty theory. So from the day one, I'm following, and a lot of good deliberation has already taken place. And these three topics are extremely potential, has got extreme potential and very emerging and relevant to current areas. And most importantly, since the advancements are taking place very rapidly in the ICT domain, so it is expected that
কথা
people
বলছেন না,
irrespective.
ফোন ধরবেন তো। আরে
Hello.
ফোনটা ধরুন, আপনি কথা বলুন দীপক স্যার, কেউ নেই এখানে। কোন দিকে একটা কোন দিকে একটা, এখন তো ওয়েবিনারটা চলছে।
Should I continue?
Yes, sir. Please continue.
Okay. So since tremendous development have taken place due to proliferation of the ICT, particularly the area of Internet of Things, Internet of Services, machine learning, cloud computing, data analytics. So thanks to the development of the development of these emerging topics, particularly related to the ICT, there has been tremendous potential of utilizing those techniques. Although some people or some researchers have got the argument to call these developments as a disruptive techniques, but whatever may be the category, still under this prevailing situation, it is imperative to utilize these interdisciplinary developments in the respective areas and carry forward the research work. Industry is now currently undergoing the Industry 4.0, which is marked by smart factory and cyber physical processing manufacturing system or cyber physical production system. So under these circumstances, it is extremely important that new and new techniques will be implemented to improve the productivity and the performance of the different organization, uh, so that the entire value chain or the entire your supply chain management can be benefited to the by using these technologies. This Industry 4.0 is basically a German initiative which was based in Hanover 2011. You know that Germany is the leading automobile manufacturer in the world, and although they have got very superior technology, so whatever different brand models which you can see, that is the Mercedes-Benz, BMW, another thing is that Volkswagen. So all these prominent manufacturers are from the German, but still they were facing the challenges of the problem that the current level of activities or current level of technology is not sufficient to cope with the increasing level of challenges either in the internal part or from the external, because currently the business is characterized by the mass manufacturing or the mass customization, where each and every customer is willing for a new product or new services or the some features to be incorporated in the particular product which that particular user is willing for. So if that is the scenario, so these characteristics or this philosophy of this manufacturing or that is the mass customization, that can be characterized by very highly innovative and complex product, immaculate product quality, last minute changes, low volume mix, and small shorter lead time, and all these stringent requirements to be satisfied at low cost. So these increases or infuse the tremendous competition among the manufacturer, and naturally the business house should strive for excellence. How to face these challenges or how to combat these challenges by harnessing new technologies. So this sort of development, there is a this performance improvement by using varieties of topic of machine learning, and to enrich these areas of implementation for the optimization of the competition part. This your mathematical techniques which are very much prominent and prevalent, that has to be integrated with this technique, so that the potential benefit can be accrued by the business house to run the show and to survive in this highly competitive environment. So I believe that this particular 5 days webinar, which has been initiated or organized by the Department of School of Applied Science and Humanities of HID Haldia, will be wonderful and will give a lot of valuable inputs to the all the participants over here. And the department and particularly the organizing team has mobilized quite a good number of eminent speakers all over the globe, which will be responsible for covering the different areas pertaining to the machine learning, linguistics, and uncertain theory of mathematics. So I do believe that this 5 day webinar will be extremely useful, and people working in the various multidisciplinary settings or areas will be able to use these theories or the techniques in their respective areas to enrich the research and to and how, and also they will think about how these techniques or how these procedures can be implemented in the real life situation to to derive or accrue the potential benefit from both the industries. I believe that this sort of webinars, which have been already initiated and organized by this Department of School of Applied Science, they will continue in the near future, and it will be considered as a very potential platform to discuss and to interact with the different speakers and participants, so that they become enriched and carry forward their work in future. Thank you.
So may I request Dr. Priyanka Dev, if some technical issues are
Yes,
going
yes.
on,
Thank
please
you. Thank you. Thank you so much,
please
sir. And we are
please
already
contact
having
our
another
next
speaker.
speaker
Yeah, we have.
so
She
that we
is
can
already
start.
here. She is already here, and we are really very thankful to Dr. Sriporna Shaha for being with us here. She is having a very busy schedule, and still she could make some time out for us in this to deliver a beautiful lecture on her area in her area. And just to introduce, just to say a few words about Sriporna ma'am, she is actually a brilliant personality, and uh, all through she has been an excellent, truly excellent student who received her MTech and PhD degree in computer science from Indian Statistical Institute. And not only this, she has also been the visiting professor in University of Caen, uh, that is in France, and postdoctoral research fellow in the Department of Information Engineering and Computer Science uh, in University of Trento, Italy, and also a postdoctoral research fellow in University of Heidelberg. And she received EMA, that is Erasmus Mundus Mobility with Asia Program Fellowship. Today, we are having this brilliant personality with us who has expertise in artificial intelligence, clustering algorithms, and natural language processing. And she is the associate professor in the Department of Computer Science and Engineering of IIT Patna. And to name a few of the research articles currently she is working on are a simulated annealing based multi-objective optimization algorithm, that is MOSA, gaps a clustering method using a new point symmetry based distance measure, unsupervised classification similarity measures, classical and meta-heuristic approaches and applications, a point symmetry based clustering technique for automatic evolution of clusters. And let me tell you, it hardly needs mentioning that it is having very high index citation. And this last one is published in IEEE Transactions of Knowledge and Data Engineering. She is truly a scholar in her field and a very nice personality. And now we are requesting Sriporna ma'am to kindly deliver her talk. Over to you, ma'am.
Yeah, am I audible?
Yes, ma'am, you're
Yeah,
absolutely.
yeah. So first of all, thank you very much, Dr. Priyanka, for giving me this opportunity to talk in this workshop. So, and thanks for this nice introduction. So, today I would like to talk about the summarization systems. So, summarization systems are an integral component of natural language processing, and it has several real-life applications. So, today I will discuss about a recent paradigm of summarization system, which is called multimodal summarization. So, as I am already introduced, so I am currently an associate professor in the Department of Computer Science and Engineering, IIT Patna, and my web page is www.iitp.ac.in tilde Sriporna. And if you have any questions or queries, you can ask me anytime during my talk. Otherwise, you can also email me in this email addresses sriporna@iitp.ac.in or sriporna.shaha@gmail.com. And my current H5 index is 30 and total citation has crossed 5,000. So this is a old data, but according to Google Scholar, my citation has crossed 5,000. So let me start with the introduction of summarization techniques. So what do you mean by summarization? So the task of automatically creating a compressed version of the text document So here text document could be a set of tweets, a set of web pages, a set of single documents, a set of multiple documents. Basically, that could be concise, relevant, non-redundant, and representative of the main idea of the text. So basically, we have to automatically create a compressed version of the text document. And here the text could be a set of tweets, a set of web pages, a set of documents, and we have to basically generate a summary of those set of documents. So a text that is produced from one or more texts that conveys important information in the original text and that is no longer than half of the original text and usually significantly less than that. So basically summary is generated from the set of text and basically it conveys important information in the original text and there is no longer than it is basically no longer than half of the original text. So summarization has several applications. So summarization helps us in compressing the information because you know the information is available in the multiple documents or multiple tweets or multiple social media feeds and now summarization is a tool to compress that information. And we are also able to identify the important theme or the central idea present in the set of documents. So basically identifying the main idea of literary and informational text. It helps us in active reading because now you do not have to spend time in reading the entire document. Rather, you can only go through the summary and you will be able to understand the important information present in the document. So basically it helps us in active reading. It is quite easy to implement and it saves our time because as I mentioned that you do not there is no need to go through the entire set of documents. Rather you can usually get a concise summary and that way it can save our time. And it also helps us in decision making process. How come? Because there is a paradigm called the microblock summarization. So microblock summarization is basically tweet summarization. So during the disaster situations people stay connected with each other through social media platforms. So people used to tweet about their situations, current situations. If we can somehow collect those tweets and then generate a summary out of those tweets, then that would be very much useful. And that information can be given to the rescue team, and the rescue team can accordingly plan for the rescue operation based on the summary. So this way, the summarization can also help us in decision making. So basically, in general, this is called the microblock summarization, and microblock summarization is useful in especially during the disaster situations because during the disaster situations, the physical connectivity is lost, and basically, people stay connected with each other through social media platforms. They used to express about their conditions or the situations through social media platforms, and as a result, if we can summarize the set of tweets then maybe we will be able to get the decision and the decision can be given to the rescue team. So in general, summarization is of two types, extractive and the abstractive. So in case of extractive, we have to basically select some important sentences. So suppose your original document is having 1000 sentences and now you have to carefully select a subset of sentences to generate the summary. So this is called the extractive summarization. So originally we have 1000 number of sentences and now we are selecting a subset of sentences to generate the summary. This is called the extractive summarization. Selecting a few relevant sentences from the original document. Relevance of sentences is decided using sentence coding features like sentence position, similarity with the title, etc. Then there is this abstractive summarization. So in case of abstractive summarization, we are not selecting a subset of sentences. Rather, we are somehow combining the original set of sentences and then we are generating a summary. So abstractive summarization includes words and phrases different from the ones occurring in the source document and it requires reconstruction of sentences. So in the original text, we have some set of sentences and now there is an abstractive summarization technique which can somehow recombine the set of sentences and then generate the summary. So summarization, here you can see the examples of summarization. So like here you can see the colored lines are selected to generate the summary. So this brown line, red line, blue line, purple line. So these four lines are selected and that gives us the extractive summarization. Then here you can see it is giving us the abstractive summarization. So here this is a paragraph, and now we are generating a summary out of that. So this is the abstractive summarization. So there are different types of summarization techniques available. So one is called the query focus summarization. So suppose there is a user query, like suppose user has given the query Taj Mahal, and now based on the Taj Mahal query we can retrieve many documents, and now we have to summarize the set of documents. So this is called the query focus summarization. So summarizing a document given a query. If you are summarizing only a single document, then this is called the single document summarization. If you are summarizing set of multiple documents, then this is called the multi-document summarization. Suppose there is a figure available and it is very difficult to understand or interpret the figure. So figure caption is not sufficient to explain the figure. So maybe the figure is, in the biomedical articles, figures play a very major role. But figure caption is not sufficient to understand the figure thoroughly. So maybe the description of the figure is written in the text. So can we consider the entire text and the figure given, and we can generate a summary for the particular figure. So this is called the figurative summarization. Now if suppose we have a set of web pages related to a particular topic, and if we are summarizing the set of web pages, then this is called the web-based summarization. Then if we have a set of emails and we are summarizing the emails, then this is called the email-based summarization. Then in some cases, maybe we can also have some personalized summarization. Maybe the user is not interested in the entire document. Maybe we have multiple documents, but depending on the user's preferences, we can select a subset of documents, and then we can generate a summary of those documents. So this is called the personalized summarization. So personalized summarization means that first we have to select importance of documents based on the personal information, based on the personal preferences, and then we have to produce summary out of that. So this is the information specific to a user's need. Now if suppose the users have given some opinions about a particular movie or about a particular product, so now if we can generate a summary of those opinions of those particular products, then this is called the sentiment based summarization. And as I mentioned earlier, during the disaster situations, there are several tweets. Users are there are several tweets, and if you can summarize a set of tweets, then this is called a microblog summarization. So microblog summarization means summarizing a set of tweets. So any system can be developed either in a supervised way or in an unsupervised way. So there are different quality measures for summarization, like we have the diversity or the anti-redundancy, we have the position of the sentence in the document, we have the length of the sentence, we have the coverage, cohesion, readability, sentence similarity with the title, etc. So diversity in the summary, diversity plays a very important role. So the sentences in the summary should not be very much coherent, like they should not convey the same information. Rather, we would like to keep those sentences in the summary which provide us some diverse information. Then in general, in a document, in a news document or in any document, you can see the past few sentences are more important. So the position of the sentence in the document plays a very major role. So the past few sentences are more relevant compared to the in later sentences. Then longer sentences are more preferred over the short sentences. Then coverage should also be high. So basically, sentences should be able to cover the entire theme of the document. And then cohesion, the sentences should be coherent to each other. Readability is an important aspect that we should be able to, the readability aspect of the summary should be high. And sentence similarity with the title should also be high. So these are the different quality measures of summarization. And basically, that we have to simultaneously optimize these quality measures simultaneously in order to produce a good summary. So now I would like to discuss about a new kind of summarization system which is called the multimodal summarization. So why multimodal summarization? Because our experience of the world is basically multimodal. You know that whenever we have to take a decision about a particular object, we used to see the object, we used to hear the sound, we used to feel the texture, we used to smell the odors, we used to taste the flavors, and then only we used to take a decision about the particular object. So our experience of the world is basically multimodal. We are using multiple sensors, multiple sensors to gather information about a particular object, and based on the information gathered by multiple sensors, we used to come to a decision. So basically, our decision depends on the information collected from multiple sensors. So multimodal learning consolidates heterogeneous data from various sensors and data inputs into a single model. So basically here we are collecting information from multiple sensors and data inputs, and then we are extracting features from those multiple sensors, and then we are making a learning system. So the approach of training models on only single source of information, such as either text, audio, video, is commonplace. But there are very few examples or very few cases where multimodal information is basically used. So, but there is also a way to build models that incorporate multiple data types. So basically in this particular work, we would like to see if we incorporate information from multiple sensors, like if we can incorporate information from text and images both, then what would be the performance of the summarization system. So why multimodal summarization? Because sometimes you already know that image is equivalent to 1,000 text. A image conveys much information compared to text. So multimodal information can help improve the overall summarization process, as it is much closer to the multi-view recognition that human beings possess. So as I mentioned earlier, so whenever we have to take a decision about a particular object, we used to see the object, we used to hear the sound or feel the texture, and then we used to take a decision. So basically it is called the multi-view cognition that human beings possess. So multimodal summaries can help improve the user satisfaction. So if in the summary, apart from the text summary, if you are producing an image summary as well, then it helps in improving the user satisfaction. So large majority of platforms like newspapers, social media, blog posts have introduced the provision of including information in multimodal format. So basically in the newspapers also you can often see the text along with the images. In Twitter also, whenever the users are expressing their opinions, then they are not only posting the text but also the images. So social media, blog posts, newspapers, all are basically collection of several information in the multimodal format. So multimodal output expands the set of concepts that can be described by the unimodal outputs. So like concepts like freedom, affection are difficult to describe using images, whereas describing what a piano looks like is also tough for someone who has not seen one before. So basically, multimodal output always expands the set of concepts that can be described by the unimodal outputs. So because there are some concepts like freedom, affection, etc., which you cannot express using images, but there are some concepts like how a piano looks like. So here it is very difficult to describe in text. Rather, we can simply display image to basically elaborate the concept. So in recent years, my research team has started working in the field of multimodal summarization, and basically we are developing different optimization based techniques for solving the multimodal summarization problem. So here as the input we have considered text and the images, and in the output also we are producing, sorry, in the input we are considering text, image and videos, and in the output also we are providing some text summary, yes, some image summary, and one video as the video summary. So this is the task, this is the basically the multimodal summarization, and our works are published in top tier venues like SIGIR, ECIR, IEEE Transactions and Computational Social Systems, etc. So let me first discuss what do we mean by TIVS task. So TIVS stands for Text, Image, Video Processing Summarization Task. So basically here we have a set of documents, D1, D2 up to mod D is the set of documents. We have a set of images, I1, I2, II is the set of images. We have a set of videos, and now our task is to carefully select a subset of text as the text summary, a subset of images as the image summary, and a video as the video summary. So here XSUM is the text summary, ISUM is the image summary, and VSUM is the video summary. So basically you can see that this approach is proposed in text, image, video summary generation using joint integer linear programming. So here you can see in the input we are considering text, images and the videos, and in the final output we have some text summary, we have few images as the image summary, and there is one video in the as a video summary. So regarding the data set, so we have used the data set proposed by this Zhu et al. So Zhu et al. Has basically developed a data set in the paper 2017, but this data set basically is having only the text portion. So the existing data contains 25 topics, each topic comprising of 20 text documents per topic, 3 to 9 images per topic, 3 to 8 videos per topic, and 3 text references per topic. So basically you know that there are this dataset contains 25 topics. Each topic is having 20 text documents per topic, some images, some videos, and 3 text references per topic. And 3 annotators are employed to score each image and video as per the text summary. So they are given the text summary, and now they are basically ranking the images and the videos in the scale of 1 to 5 on the basis of similarity to generate the multimodal summary. And then we are selecting top few images as the image summary and the top video as the video summary. So average annotation scores were calculated for each image and video, and multiple images and videos are selected based on average annotation score to evaluate the model. So in the past work, we have proposed a joint integer linear programming framework for solving the problem of text, image, video summarization. So basically, you know, here we have a set of text documents, we have a set of images, we have a set of videos, and now we are applying some optimization technique to carefully select a subset of sentences as the text summary, a subset of images as the image summary, and a video as the video summary. And this work is accepted in European Conference on Information Retrieval, or ECIR. So this is the overall flowchart of our proposed approach. So we have the multiple documents. From the multiple documents, we are collecting the important sentences, the unique sentences, and these unique sentences form the text set. Now the images are added to the image set, and from the videos we are generating the speech transcripts, and we are also extracting the keyframes. So these keyframes are basically added to the image set, and the skip transcripts are generated, and the skip transcripts are basically added to the text set. So basically we have text set and the image set as the input, and now there is a joint integer linear programming framework. So this integer linear programming framework takes input the text set and the image set, and basically it generates some text summary and some top k images as the image summary. So basically you know that text summary, it is basically producing some text summary. In the text summary we have a set of sentences, and in the image summary we have a set of images. Now we are basically applying some post processing technique, and basically we are adding some more images in the image summary, and we are selecting a single video as the video summary. So basically you know that this is our final output. So this text summary is kept as it is, but now the image summary is enhanced by adding some more images. So this is our final image summary, and there is a one video in the video summary. So this is the proposed model architecture. So what is the basic skeleton of the linear programming? So there are decision variables, the variables whose values are to be set to find corresponding solutions. So we have the objective functions. Each decision variable is having some objective functions. So here we have multiple objective functions which are either maximized or minimized to find the optimal solution, and there are some constants. So each of the solutions must satisfy some constants. So restrictions used to formulate a problem and incorporate real life knowledge or intuitions. We have used the Gurobi optimizer to perform the integer linear programming optimization. So Gurobi optimizer is used to optimize this particular framework. So here this is our decision variables. We have some binary matrix of size n by n. N is the number of sentences in the document. So mij text. So here the diagonals represent whether that particular sentence would be a center or not, and then mii represents that particular sentence would be a center or not, and mij represents whether the jth point belongs to the ith cluster. So if the ith point is a cluster center, then jth point may belong or may not belong to the particular cluster. So basically mij denotes whether the jth point belongs to the ith cluster or not. And then we have a image matrix also, I image, having size p by p. So where p is total number of images. So here again the diagonals represent the image centers, and then the other values represent whether a particular image belongs to a image cluster or not. And we have the cross model matrix MC. This is of size n into p. So basically Mij is basically Mij would be equal to 1 if there is a threshold level of correlation between Si and Ij. So if there is a threshold level of correlation between Si and Ij, then Mij would be equal to 1. So we also want to make the image clusters and the text cluster similar, because that is our another goal. So as the objective function, it is, it is a combination of multiple objective functions. So it is a combination of three objective functions. One is the saliency of mtxt, saliency of image, and the intercorrelation saliency. So saliency is the saliency score for a given matrix. So underscore correlation is a multimodal correspondence. So saliency of text is basically nothing but this. So here you can see that the MII represents whether the ith sentence is a cluster center or not. So MII represents that ith sentence is a cluster center, and this important of item G item represents the ith cluster. So G item contains all the sentences which belong to the ith cluster. And important of item I, G item I is basically the cosine similarity between the cluster center and all the other items in the cluster. So basically important item I, G item I, this represents the cosine similarity between the center and all the other points in the cluster. And this MII is basically, this is, you can see, this means that ith point is a cluster center. So saliency is basically nothing but the compactness. It is trying to minimize the intra-cluster compactness. So the similarity between the center to all the other points in the cluster should be high. So saliency has to be basically maximized. So here we have calculated the saliency of the text clusters, saliency of the image clusters, and then this is the cross correlation between the image and the say text. So here you can see that this is basically the cosine similarity between the sentence and the image. So we are also trying to improve the correlation, cross correlation of this matrix. So basically we are optimizing, basically we are trying to maximize this objective function by using the Gurubi optimizer. So this is the integer linear programming framework, and we are optimizing this objective function using the Gurubi optimizer. So there are several constants. So like all matrices are binary. So Mij mod equal to 0 or 1. So you can see that either a particular point would be a center or not. It will not be a center. So basically you know that all matrices are binary. There must be exactly k txt and k image clusters in the respective unimodal space. So you can see that if we count the number of diagonals which are equal to 1, that count should be equal to k txt, because k txt is the number of text clusters. And if we count the number of diagonals equal to 1 in the image matrix, then that should be equal to k image. An entity can either be an exemplar or be a part of a single cluster. So you can see that either an entity could be an exemplar or be a part of a single cluster. And for an entity to be endorsed by any other element, it must first be an exemplar in the vector space. So basically these are the constants.